So you're having trouble with the limit process. Keep watching. I've got 3 examples to show you. Hello, my fellow math nerds. My name's Mark Noldy, rhymes with moldy. I've been teaching students for almost 25 years. And I always tell them when they get to calculus, they find out if they were any good at algebra. Like the algebra needed to do limit process. Not that you'll ever do it this way in real life, but hey, it's on the final exam. So here's a basic expression. F of x is 3x plus 4, right? Simple linear. We know that a line, 3x plus 4, has a slope of 3. And we know that the derivative is the slope. So I always tell students, do what you know how to do first to figure out the derivative before you do one of these limit process problems. That way you know what it is you're working toward. So as we know, the derivative, the definition of a derivative, the limit definition, is the limit as delta x approaches 0 of f of x minus or plus delta x minus f of x, which is, of course, y sub 2 minus y sub 1, and in the denominator it just becomes delta x because y sub 2 or x sub 2 minus x sub 1, those add off and we're just left with the delta x. So in any event, this is my formula. I'm going to use this expression and I'm going to figure out that the derivative is 3 using this formula. So let's do first things first. We're going to say that this is equal to the limit as delta x approaches 0 of, 3 times x plus delta x plus 4. Forgot a parenthesis. So this is my, this expression here. I substituted x plus delta x in place of this x. So it's 3x, only it's x plus delta x, plus our 4, minus, so minus gets a minus, and put parentheses around this. I always tell students you got to put parentheses around this. Otherwise, things won't add off in the end the way you expect them to. So we'll go through, let's distribute here. So I'm going to distribute 3 on the x and the delta x, and then I'm going to distribute this negative sign on the 3 and the 4. I'm sorry, the 3x and the 4. So let's do it. The limit as delta x approaches 0. This is one of the pain in the neck points. A lot of students don't like to write this down, but it technically needs to be there, especially on our final exam. So let's go ahead. 3x plus 3 times delta x plus 4 minus 3x minus 4, because remember I distributed this minus 1 on both of those terms, and it's still all over a delta x. So one thing that happens for us is a lot of things go out. Plus 3x and minus 3x add off, they add up to 0. Plus 4 minus 4, they add off to 0. So the only thing that we're left with, let me scooch this up a little, is the limit as delta x approaches 0 of 3 delta x over delta x. Those are the only two things remaining. This term here, 3 delta x and delta x. A lot of people would go straight to a 3 here, and a lot of textbooks do that, by the way. And if a student's just learning this stuff, it's kind of, if they don't show every single step, sometimes it's easy to get lost. So for that reason, I like to show every single step. I always tell my students, I'm stepping this out. So, delta x divided by delta x cancels. Because remember, this is not exactly a 0. This is really close to 0. So approaching 0. So it's non-zero. So they are non-zeros and they add up. So there's not even a 0 to substitute anywhere in this expression. The only thing that's left over is a 3. And that checks, right? That checks with what we had up here. This is what we were working towards. So it's nice to have something to know that you're working toward. So there's an easy example. I'll show you one that's a little bit more complicated next. Now here's an example, I'd call this medium difficulty. It's just a little bit longer polynomial. It's a quadratic polynomial. So before we were looking at just a linear. I had 3x plus 4. Now we've made it 3x squared plus 4x plus 1. Now, because I'm practicing for final exam, I know using the power rule that my derivative should come out to be 6x plus 4. So that is this expression. This is what I know I'm going toward. In the beginning, when students are first learning this process, they don't know about the power rule to do this. But when you're studying, like I said, for an exam or a final exam, and you know you're going to have to do this process and that it's algebra intensive, it's good to know what you're working toward. So let's go ahead and figure out this using this process, the derivative of this function using our limit process. So I'm going to substitute first. Oops, let me change my color back so I'm consistent here. Equals the limit. And again, this is the part that's the pain in the rear to write down every time. So I'm going to take 3 and then x gets replaced with x plus delta x. And that is being squared, right? So it's x squared, so x plus delta x squared. Plus 4x, so I'm going to put in a 4 x plus delta x. And then I've got my 1. Don't forget the 1. I forget it all the time. Minus the function. Put your parentheses because you're going to subtract every one of these terms. So 4x plus 1. All right, and then that is all over delta x. So what we're going to have to do is FOIL this. This is x plus delta x times x plus delta x. So go ahead and FOIL that. So still have limit as delta x approaches as 0. So this will be 3 times x squared plus 2x delta x plus delta x squared. Distribute this. So that's a plus 4x plus 4 delta x plus 1, and then I'm going to distribute this minus 1 on the function. So it's minus 3x squared plus 4x. Whoops. That's not distributing a minus, is it? That becomes minus 4x minus 1. It's still all over delta x. All right. Looks like now I can distribute this 3 on x squared, 2x delta x. I'm missing an x in my delta x there. I see. So I'm going to distribute that. So continuing with my limit. The limit as delta x approaches 0. 3x squared plus 6x delta x plus 3 delta x squared. Already distributed this in the previous step. So that's just coming along for the ride. Plus 4 delta x plus 1 minus 3x squared minus 4x, and running out of space here. This happens sometimes. So, all over. Don't forget the all over delta x. So, here's where some nice magic happens. 3x and minus 3x. Or I'm sorry, 3x squared and minus 3x squared. Those add off, plus and a minus, they add up to 0. Then we have a 4x and a minus 4x, and a 1 and a minus 1. So everything has canceled out basically that doesn't have a delta x in it. So equals the limit. Can't get rid of this until we go to direct substitution, correct? So it's 6x delta x plus 3 delta x squared plus 4 delta x. And let's see, that's it. 1, 2, 3 things. And it's all over delta x. So a lot of times you can tell if you're doing these right if you have all delta x's left up in the top, because we're going to factor a delta x out to cancel with the one in the denominator. So let's do that next. The limit as delta x approaches 0. Okay, so we're going to undistribute, if you want to call it that. We're factoring out a delta x. Now notice here I have a delta x squared. So when I factor 1 out, delta x times delta x is my delta x squared plus 4. We took out that delta x. All right, now delta x over delta x is 1. So I'm going to go to direct substitution now and put a 0 in place of delta x. So that would give me 6x plus 3 times 0 plus 4. And there we have it, 6x plus 4. So I'm going to go back up, double check. Is this the same as what I knew the answer would be using the power rule? Scroll back up, and yupper, right there it is. So watch this a few times if you need help with it. Sometimes seeing it explained instead of looking in a textbook at it, that helps a lot too. But let's go on to one. I'll give you a cubic to look at next. For this last example, I wrote tough here with a smiley face, but it's a cubic now. And I notice it's the same 3 numbers, trying to keep it similar for everybody. So 3x cubed plus 4x squared plus x minus 7. So I know from using the power rule that this is going to be the derivative of it. But we're studying for the final exam, so we're going to pretend that we don't know this, but that we're just being asked to use the limit process, which is this right here. So go ahead, make our substitutions. This is going to be the limit as delta x approaches 0 of, okay, so I have to put x plus delta x in place of x in each and every one of those cases. So let's go ahead and do that. X, 3x plus delta x, quantity cubed, plus 4 times x plus delta x, quantity squared, plus x plus delta x, minus 7, minus now the whole function in parentheses here. So minus 3x cubed plus 4x squared plus 1x minus 7. And the reason we do that is because we know we're going to have to distribute this negative on all 4 of those terms. So once again, this is all over delta x. All right, so going to have to move around on this one maybe. So we've got a limit of delta x going to 0. 3. I'm just going to use the binomial theorem here. If you don't know the binomial theorem, actually, if you don't know the binomial theorem, go ahead and hit me in the comments below, and I'll make a video on it. But I'm going to use the binomial theorem to expand the x plus delta x. So it ends up becoming x cubed plus x squared. Actually, that's going to be 3, isn't it? 3x squared delta x x plus 3x delta x squared plus delta x cubed. Ooh, binomial expansion theorem to the rescue again. Plus, let's see, I'm going to have to expand this one again. We just expanded this in the last example. X squared plus 2x delta x plus delta x squared plus, oh boy, running out of space quickly here, plus x plus delta x minus 7 minus 3x squared cubed minus 4x squared minus x plus 7, because negative, negative of negative is positive 7. So that is, boy, that is a long numerator. This is one thing that sometimes students don't like, is because they take up a lot of room on your paper. All right, no doubt about it. But everything is still over delta x. But piece by piece, we will get there. So the next step is to distribute this 3. So 3x cubed plus 3x squared delta x. Oops, take that back. What's 3 times 3? That would be a 9x squared delta x plus 9x delta x squared plus 3 delta x cubed plus, oops, I see I'm running into some business up here, so I'm going to curve it downhill a little bit. 4x squared plus 8x delta x plus 4 delta x squared plus x plus delta x minus 7. Now I'm on to minus my function. Minus 3x cubed minus 4x squared minus x plus 7. And again, this is all over delta x. I'm going to have to make my fraction bar keep coming over here. Ooh-wee. Feels good after you do a long problem like this, though, and you've done it right. All right, now is when we can get it whittled down a little bit. I know this is going to go out with this. We know that 4x squared will add off with negative 4x squared. X adds off with negative x, and negative 7 and positive 7. So watch how much less we have to write on this step. Equals the limit as delta x approaches 0 of, got 9x squared delta x. We should only have delta x things left because we're going to factor it out. Plus 9x delta x squared plus 3 delta x cubed. Let's see, plus 8x delta x plus 4 delta x squared, and there's one more, plus delta x. And this is all over delta x. So I'm going to factor out a delta x. So here's the spot where we factor a delta x. So this delta x is going to come out and leave us with 9x squared plus 9x delta x. So be careful here. There are delta x squared is here. So delta x times delta x was this delta x squared. So be careful when we have higher exponents. Plus 3 delta x squared. So this one is going to stay squared. Plus 8x plus 4 delta x plus, and this is a tough one. A lot of times students will mess this up. They think it comes out and it just goes away. But there's still a 1 there. There's 1 times delta x. So that is going to end up being part of our derivative. So we have to make sure that both that this comes out, but the 1 stays behind. Still all over delta x. So in my next step, I will cancel these, or I'm going to cancel them right now. So in my next step, I'm going to go to, actually I'm going to go to direct substitution now. I think we can do that. So that means I have 9x squared. This is going to go to 0 because it's plus 9x times 0. Delta x is 0. Plus 3 times 0 squared. So here's another term going to 0. Plus 8x plus, this is going to go to 0 because it would be 4 times 0. Plus 1. So when I simplify or hack this down a little bit, we end up with 9x squared, gone, plus 8x, gone, plus 1. So if you check where we started, I think you'll find that we did pretty good here. So this is my derivative using the limit process. And let me know in the comments below too if you want to see a limit process of how to do summations. They can make one of those too. So anyway, here is double checking. Yay, here it is. So we did do this the correct way. So that is the tougher one. So if you want to call it that. But they're all polynomials. Nothing we did was fantastically hard. It was just algebra intensive and is very easy to make a simple mistake. If you got value out of this, please hit the like button and subscribe. This helps others searching this content. And as always, remember, math is not a spectator sport. The only way to learn math is to do math.